Hey everybody, this is the homework that is due Thursday. So let me center this. So I tried to make it bigger font so you could read it. Please have this problem in your composition notebook. It's not too long. So it's just going to be one problem. I'm going to teach one problem and then I want you to do this one here. Okay, so the first one. Mr. Corbett is standing 15 feet away from a lamppost and casts a 10-foot shadow. I'm putting my hand here because this is for later. If Mr. Corbett is 6 feet tall, how tall is the lamppost? So, and I'm also going to try to speak extra loud so it comes out clearly through the video. So the way that we can do this problem is actually, it's fairly similar to a problem that we did today. It was the problem that looks something like this, where there was one building here. These are supposed to be windows. And then there was a building off in the distance like this. Now, how we did this is we broke it down into two big triangles, this being one of the triangles here, and then we broke off the small triangle, and then we used these distances here to set up a ratio. So we're going to, or a proportion between the two ratios. So we're going to do the same thing here. Now Mr. Corbett is standing 15 feet away. So I can draw Mr. Corbett right here. Yeah, okay, he's got really long deer-like legs. I'll draw the bow tie, I guess. I might as well draw my little thing. I got big ears too. Okay. There's a weird-looking Mr. Corbett. And here's the lamppost. I don't know how to draw a lamppost. There's my lamppost with some light coming off. Okay. I didn't go to art school. Okay, so lamppost, and here's Mr. Corbett. Mr. Corbett is standing 15 feet away from the lamppost, and he casts a 10-foot shadow. Now, if Mr. Corbett, this distance right here, is 6 feet tall, I'm approximately 6 feet tall, how tall is this lamppost? So this is what we're solving for here, x feet. Now, the way that we're going to do this is there are two triangles. Now there's one triangle here, and these are similar triangles. Similar, meaning same shape, but different, try to predict, different sides. Similar figures are same shape, different sides. Okay, so there's one triangle here, and then the bigger triangle is all the way here. It's all of this. And so we can compare these two triangles. So what we'll do, what I like doing is drawing the bigger triangle, and then also drawing the small orange triangle. You can be much neater in your composition notebook. I should model be neat as well. And here's the big green triangle. Okay, so here's the entire triangle. Now we're trying to solve for this x. And we don't know this distance, but we know parts of it. So let's see. This chunk right here is 15 feet. And this chunk right here is 10 feet. So the entire thing is going to be 15 plus 10, which is 25 feet. Now, the smaller triangle, we know everything here. This distance right here, Mr. Corbett's shadow, is 10 feet. And my height is 6 feet. So now, in these two triangles, I can set up the proportion. Move this up just a little bit. So we can have x over 25 is equal to 6 over 10, x over 25, and these are the sides that are corresponding. I'll label these. And these sides correspond. So x over 25 and 6 over 10. Now there's several different ways I could have set up this proportion, but that's one way you could do it. If I also did something like x over 6, now try to predict what the next two sides are going to be. It's going to be, so we start with the green triangle, so it's going to be 25 over 10. And so these are two proportions that I could use. Now notice, I'm going to be multiplying here, the cross multiply. I'm going to get the same thing with both. 25 times 6 is going to be 150. And that's going to be equal 10x. Here the same thing is going to be 6 times 25, which is 150. And that's equal to 10x as well. Divide both sides by 10. I guess I really don't need to do both problems. But x is going to be equal 15. So the height of the lamppost, x here, is 15 feet. So going back to the original problem, this height right here is 15 feet. So this is actually how you can measure mountains. I mean, let's say I didn't have a ladder or anything. We can use geometry such as this to solve for the distance of Mount Everest's height. So interesting fact, I threw an interesting fact in one of the other videos. Mount Everest is the highest mountain in the world. I think it's about 29,029 feet, something around there. There are different measurements. Scientists, you can't have an accurate measurement because you can't drill. I just want to get in front of the. Hi. Okay, because you can't drill a hole directly from the top of the mountain directly down and measuring its exact height, but you can use geometry such as this to try to figure out a good estimate for Mount Everest's height. Now, the original height of Mount Everest, they they measured it exactly at 29,000 feet. This was one of 50 or hundreds of years ago, and they didn't think people would believe them that it was exactly 29,000 feet. So they decided to, I think, add or subtract 3 feet to make it seem more scientific. Because if they told the scientific community in the world Mount Everest is 29,000 feet, it doesn't feel as exact as 28,997 feet, right? I mean, a bunch more numbers seems a little bit more scientific. Okay, so there's a random fact of the day. Now let me point you in the right direction for this problem here. I'll leave it still, and let's see. Okay. We'll move it up here. Okay. So when Mr. Corbett was in 7th grade, scratch this. He wanted to climb the tree in his backyard. Mr. Corbett knew that the tree was 20 feet tall, and when he stood 10 feet away from the tree, he cast a 3.5-foot shadow. How tall was Mr. Corbett in 7th grade? Sorry, Fernando. Was he shorter or taller than Fernando Mata? Was he shorter or taller than the people's champ, Brandon Green? Okay, so what we could do is the tree can be here. Mr. Corbett, as a kid, could be right here. Let's see, I'm just going to... Now he stood 10.5 feet away from the tree. So this distance right here is going to be 10.5. And he cast a 3.5-foot shadow. So my fault on the drawing. Mr. Corbett probably should have been a little bit over here to make it seem realistic. But this is still how you would set it up. And Mr. Corbett, we know how tall the tree was. 20 feet. So we're trying to find this distance right here. This was indeed my height in 7th grade. So here's one triangle. And then use this triangle as well to help you. All right, please submit your answer on that puzzle. I'll leave this diagram just for a few seconds if you want to copy this down. And now here. I'll leave this here just for a few seconds if you want to copy this problem down. It's nice and big. You don't need the Fernando Monta granted in your notes, just how tall is Mr. Corbin's seventh grade. All right, thank you very much, everybody.